Assalamualaikum and good morning. We continue last week rounding function. We will refer to page 57, section 3.3.2. So MATLAB contain function for a number of different rounding techniques. See this table, table 3.2. For example, suppose you want to buy apple at grocery store. So the idea of rounding function. So mathematically, $5 over 0.5. You have 52 cents per acre, you get 9.6154 acres. So you can buy part of an acre. It's the one that you run to the nearest number of acres. Instead, you need to run down. So the MATLAB function to calculate this is fixed. That's fixed 5 over 0.5 to return the maximum number of acres you can buy is 9. Some of the example of the rounding function. After there are 5 command code to rounding function. Round x is to round the number to nearest integer. Round x and round x to specify decimal digit. Example here, 3 decimal digit. X round or truncates x to the nearest integer toward 0. Notice that 8.6 truncate to 8, not 9 with this function, because it truncate around to the nearest integer toward 0. For flow around x to the nearest integer toward negative infinity. So flow negative 8.6 is negative 9. Seal x on x to the nearest integer toward positive infinity. So similar number, 8.6. Seal answer is negative 8. Do this exercise. Find the nearest integer of 3.2 and negative 2.3 by using both fixed and flow. Explain why there is a difference in the result of the fixed and flow function between the two cases in your answer. So to do this, you need to define numbers. Then you do flow x still x. There's a different here. The different you can refer to it's like y. It's not C. Okay. Fixed flow. Fix x. Oh. Discrete mathematics. Discrete mathematics is the mathematics of whole numbers. MATLAB include function to factor numbers, find common denominators and multiples, calculate factorials, and explore prime numbers. To calculate a factor in MATLAB, use the factorial function dash factorial 5 120. Give the same result as I times 4 times 3 times 2 times 1. That is a factorial. The value of a factorial quickly become very large. The factorial is 3 million, 3.6 million. And MATLAB can handle up to 170 digit. Anything larger give INF infinity for an answer because the maximum value of a real number that can be expressed in MATLAB is exceeded. The MATLAB code to perform this conversion is degree equal to radian times 180 over pi. This is trigonometric function. Refer to page 91. MATLAB includes several set of the standard trigonometric function and the hyperbolic trigonometric function. S is standard in most computer language and in common mathematical usage. Most of these functions assume that angle are expressed in radian. So in MATLAB, the angle is expressed in radian. To convert radian to degree or degree to radian, we need to take advantages of the fact that pi radian equal to 180 degree. So you can actually convert radian to degree using this calculation. MATLAB also include the function to convert from degree to radian. So if you use, you can also use code command deg to rad, radian to degree, rad to deg, deg. And for the convert pi radian to degree, use rad to deg in round bracket pi. We get 180. There are two methods. This or using the command. So MATLAB also include a set of trigonometric function that accept the angle in degrees so that you need not do the conversion to radian. This is called SIND, sin, cos, and tan. MATLAB often use the notation sin minus 1x to get an inverse sine function, also called arcsine. Students are often confused by the notation. Try to create parallel MATLAB code. Note, however, that a equal to sin to the power of negative 1x is not a valid MATLAB. Instead, you should use a sin. This is inverse sine function, a sin. This is table 3.4 show all the available command under trigonometric function. Degree to radian, radian to degree conversion. This is normal, sin x cos tan x. This is the inverse of arcsine. Hyperbolic sine, inverse hyperbolic sine, and this is sine where x is expressed in this in degree. So if you use this sine x without d, it is actually the x is expressed in radian, and yeah, so on similar. Using trigonometric function, This is about finding the force. See, find the resulting force on the balloon. You need to note the input here is gravity, buoyancy, and wind, and the output is the resulting force. So do the hand calculation first. In this case, we need to use script file. See here, comment example 3 2. Here, this is the comment define the input. Then there's a comment to convert angle to radian. Then they find the force X. So exercise in the right angle triangle, if the base of the triangle is fixed at 3 cm, the angle closest to the base varies between 10 degrees and 70 degrees. Compute the 3-row metric in one row showing the varying base with 1 degree increment, and the other 2 rows showing the height and hypotenuse of the triangle as the base angle varies. So you have how many columns? Many columns, but 3 rows. So that column is from 10 to 70 degrees, 1 degree increment. So 70 column. For the hypotenuse, you can refer to the map to calculate the height and hypotenuse. So for the angle here, you can use normal column method. Normal column method. Then for height and hypotenuse, that one is calculated based on the degrees. The displacement of a oscillating spring shown in figure 3.11 can be described by x equal to a cos this one t. So find the displacement x for time from 0 to 10 when the maximum displacement is 4 cm and angular frequency is 0.6 radian per second. So for this, we need to create a vector. If you use the column method, so 0 to 10, column in the middle, 0, column 10 in square bracket. No, in yeah, square bracket, you get evenly spaced for one increment. Yeah, you can try this exercise as well. So all of this exercise require you to create a table. So to create a table, you need to use this apostrophe to transpose. Return this function, to page. Refer to page 95. Analyzing data actually in MATLAB is particularly easy, partly because all data set can be represented by a single metric and partly because of the large number of built-in data analysis function. So this is the list of function for maximum and maximum in a data set. For example, max x, find the largest value in a vector x, for example, x equal to 153, the maximum value is 5. All the function in this section work on the column in two-dimensional matrices. MATLAB is column dominant. In other words, there is a choice to make. MATLAB will choose column first over row. Column is like this, vertical. For example, if you want to find the maximum value in each row of the matrix, you need to transpose it. Because why? Because MATLAB prefer column over row. So you need to transpose X, which return 5 and 6. 5 and 6. Another approach to solving this same problem is to specify dimension to be analyzed. Since MATLAB is column dominant, columns are specified as dimension 1, rows are specified as dimension 2. The dimension must be entered in the third input field in the max function. Since most commonly the second field is not used, this requires a placeholder, thus find the maximum in each row of the X matrix. So max bracket X, this is the placeholder 2. Return the answer is 5 and 6. This is refer back to X equal to this matrix. If you choose 2 here, it refer to the row. A common mistake when finding maximum minimum value in a data set is to name the value the result max or mean. This override the function and the function is no longer available for calculation. For example, max equal to max x result in a variable named max for the answer. This is allowable MATLAB code, but it's not wise because trying to use the max function later in the program will result in error. So don't use the code or the command as the variable like this. Otherwise, if you want to calculate another max, yeah, it will return index exit metric condition because at that moment max is not a command but a variable. You do this exercise. So to do this exercise, you need to define this x first. This is 4 times 4 metric. What is the maximum value in each column? So this is the column. So how to do that? You need to use the code in table 3.5. You can use max x here. In which row does the maximum occurs? That one you need to use a b equal to max x, so on. Mean and median. Mean and median is page 97. In statistic, the mean of a group of value is probably what most of us would call the average. The mean is the sum of all the values divided by the total number of values. Another kind of average is the median. The median value, the mode is the value that is most often in a data set. This is 3. So average, mean, median, and mode. You can try this exercise. It's similar, but question is not similar, but X, define X is similar. So it's easy to use a script file to do this work. You can see many answer here. two other exercise. The vector G, define vector G, represent the distribution of final grade in dynamic force, and check the mean, median, mode, and standard deviation of G, which vector represent the most typical grade. The mean, median of mode Y. Use MATLAB to determine the number of grades in the array, just count them and sort them into a single order. If you don't know how to calculate the standard deviation, you can use either HAP standard deviation or dog standard deviation. How to sort them in order? Yes, can also have sorting, DOC sort. Okay, for exercise number 3 here, under mean and median, you need to specify this or to define this table first. Not one by one, but as a 3 column. Then you find the minimum temperature of each thermocouple. I think sum and product we will continue in week 5. Thank you. Do the exercise. We will continue after the Raya Festi. Happy holiday. Thank you.